we've already talked a little bit about functions, and the exercise that we started doing last week, that was a functions exercise. So now let's just look at the theory about it, sort of put those things in our mind a bit, but try and sort of relate it to a little bit of the theory of where it goes, right? So here's a little definition or explanation of functions. Another word that we use for functions is a subroutine, sequence of instructions. Yeah, so typically we see something that might be used more than once. We see, okay, we got this bit of code. We could use this again and again, maybe. That would be an ideal situation to make a subroutine or a function. So it's typically going to have some inputs. Doesn't have to. Don't have to have inputs for a function, but you have an opportunity to put inputs. We had a special word for them. We called them parameters, or we might also call them arguments. It will typically have a output. Again, doesn't have to. When we had an output for a Python, you guys are a long way away from me. When we had a output for a Python program, that was done with a return statement. Return and then the name of the thing that we want to output. You can only output one at a time. That's the problem with that. The Python function, as it says, we have to give it a name. And so we give it a name the same as we do other sort of objects and variables, etc., in Python. So we do that. And yeah, in a flowchart, we can represent a process, which is a special process, which is a function, by putting double lines on the sides of it. So that's that representation there on the sides. On the sides here, that means that it's a function in a flowchart. So when we go to create a function, we use the def, and then the name that we want to use. That means that we're defining a function. Then we give the name. We open up some brackets. If there are any parameters, we'll put them in the brackets. Otherwise, the bracket can remain empty, but we do need to put the brackets there. The colon, we use that everywhere in Python, as you know, whenever we want to start a control structure. But we also use that when we're defining a function. Then we put in our code, and the code will be indented. Colon always makes things indented. If we've passed any parameters as input in, then they will be used in the program. And lastly, we're going to have a return statement, which is going to pass out the output. We can only really use one sort of output. All right, so some other things about functions. We use their name. We have this, so this word here, called, that actually has quite an important meaning. So I hope we got that idea when we talked about functions before. Functions, there's two steps in the use of a function. The first step is we have to define the function. We just talked about that. The function won't do anything until it is called. So we have a statement where we call the function. And in that statement, we reference the name of the function. And if there's a return value, we'll create a variable usually. Don't have to create a variable, but we'll take that return value and we'll do something with it. Often we'll assign it to a variable. Often, but we can use it other ways. We could just print the result of a function. We could just pass it to another function. But sometimes we'll just we'll assign it to the value of a variable. So what have we got here? We have a flowchart which represents a function being used. So the function is represented to the left. So that's our average. The name of the function is average 3 XYZ. And what it does is, if you look at that function, what it does is it takes 3 variables which are passed to it, and it adds them together, and then it divides them by 3, and then it returns the result. Now, over on the right shows how that function fits into the overall program. Before that function can be properly called, this black thing here represents the function in the flowchart, and that's why it's got 2 lines on the sides. but it also represents a statement that we would use to call the function. That's where the calling of the function kind of looks like this. So in this case, we've set a variable called overall, takes the value that is returned out of, or the output from the function average 3, where that function has 3 variables passed into it. So these 3 things here are the parameters or the arguments, and they are passed into the function. And then when the function is performed with those 3 things, they're passed in as assignment, quiz, and test, but inside the function, they become X, Y, and Z. Now, how they are assigned in that call of the statement is by their order that they are put here. So assignment is the first one, so it becomes X. Quiz is the second, so it becomes the second over here, so it becomes Y. And test is the third, so it becomes Z. That order is very important. If you mix the order up, then your function won't work as you thought it would. So that's very important. What we're really saying here is the first parameter, the second parameter, and the third parameter. And how are they used? They're used like this. So what happens is in this particular program, we're getting input, which gives us the 3 parameters. So we have a parameter for assignment, for quiz, and for test. Those are passed into the function. The function then transforms them, I guess you could say, into X, Y, and Z according to the order which they're passed in. And then they are operated on to a new variable is created there called S, which is the sum of them. And then another new variable called A, which is S divided by 3. And then A is returned out. So A is going to be returned out. What will happen is overall we'll take the value of whatever is A, and then we can print it out. Okay, so here is that put into a program. So at the start, we're defining the function. 2-step process, right? We define the function. The actual program, and perhaps it would be nice if we put a little comment here just in front of the word assignment, but the actual program starts here with assignment. This is not the start of the program. This will not do anything. This DEF thing will not do anything until we call it. All this does is define the function. So somewhere we have to call the function, and you can actually see that down here. So the first thing that happens is we have these 3 input commands, and what happens there is the user is asked for numbers 3 times, and those numbers are the assignment, the quiz, and the test. Then we call the function, and calling the function, we pass into the function as parameters in the correct order, the assignment, the quiz, and the test. And then from that, the function does its calculation, returns the value. That returned value is assigned to a variable called average, which we can then print. And so that's the same as the flowchart. But the program starts here, where my cursor is now. Okay, so that's a function that you create yourself. We go and create a function, we do the DEF thing. So the point of this slide now is that there's other functions. Python has a bunch of functions that are already created for you. So you don't have to define them, but you can call them and run them the same as you did the other one, right? And so some of them we've already used. Int, str, float. We call this casting. Casting means we change the type of the variable. So the variable might be a string, and then we change it to an integer. That's, for example, we use this with the input command, didn't we? Because anything that's input is going to be returned as a string. And if we want to use a number for any kind of calculations, we're going to have to convert it to either a float or an int so that we can use it for any mathematics. Likewise, if we want to print something out by concatenating strings, and we've done that with a lot of our print statements, and we have some kind of integer variable, we'll need to change it to a string before we add it to any other string. And so we can do that. We can take a integer and convert it to a string and then add it to another string. We've already used this one as well. If you have a string, so when we were playing around with strings, we've been doing a bit of playing around with strings, do a bit more, I suppose. The len function, what that does is it returns a number, which is how long is that string in the number of characters that it has. Input what that does is that puts up a message string to the user on the screen, and then it accepts whatever they type and returns that value to another string. And print also will take any variable and print it. All right, so there's many more. So we've got a bunch of math ones. So absolute value. So that'll convert a negative number to a positive number. Power, two numbers, right? We'll raise the power, the base to the power of the y. ASCII will give you the ASCII character for any particular character. CHR is sort of related to that. That's the reverse, the character from an ASCII. Bin will give you the binary. I wrote a little program for you for this, right? Well, you don't have to, because there's a built-in function to do that. We'll give you the binary value of a number. And hex will give you the hex value. Hexadecimal is used a lot in computing. So, all right, that brings us to this thing about libraries. The idea is that code should be as simple to use and reusable as possible. So you have programmers that go and write nice little codes, little functions, some of them a little bit more in, procedures that could be used, could be generalized, and could be used by other people a lot because it's a common sort of need. Well, those things will be saved in a bunch of Python code, and those things can be put onto a website, for example, or distributed on a CD or something like that. But what you can access little programs that other people have written that will do things for you that will make your programming easier. When you do that, you're going to have to import that library. So we have this thing called import. Now, the library will actually have to exist in a place where you know where it is. When you installed idle Python on your computer, you would install a whole bunch of files with it, including a bunch of these libraries. So those libraries are there, right? So for example, there's a math library there, but in order for you to access it in your program, first you'll have to import it. So you'll have a little command that'll say import. The library's already there, but you need to import it. Python will not access it until you import it. If you want to get some more specific library, you'd have to go and grab it from the internet somewhere and then install it and then import it. Or else sometimes you can just access a library by referring to a web page, you know, where not a web page, a URL, a website where that library exists. So the math library has some special functions that we can use, like square root and pi. Yeah, you need to say where you got it from when you actually run the function. And so I think we got one here. Yes, so you don't need to install the math library. It's installed on your computer, right? But you would need to import the math library. And then when you go to run the program, as you do here, what we're doing here is we're saying we're going to run the square root function, which is a method of the math library. So the math library is there. We're going to run the square root method, and we're going to pass in these parameters, the area, and we're going to use the pi, which is just a special number, as you know, which is also found in the math library. And so that could be used in a program for a circle. Bunch of other methods. All right, so some of these we've seen. If you have a string, so you can say the name of the variable which contains a string, then the dot, which means that this string is being treated like an object, and then we have methods that work on that object. So we have the lower method. We don't put anything inside these brackets, all right? We just say dot lower. That will give you all lowercase for that string. Dot capitalize will capitalize the first letter, but not the rest. The rest will be lowercase. Then you've got upper, okay, which would be, yeah, there it is. Upper, that will put all the characters in uppercase. Now we got some other ones here. Look, this is a test. Okay, this is a test. So it's going to return true or false. It's Boolean. Is it true or is it not? So we can have a string and we say dot is upper. If it's upper, it'll give you true. It'll return true. So we can use this in an if statement. Likewise for lower. So is it uppercase? Is it lowercase? Is it a number? Is it alphanumeric? Or is it all the numbers and things? Is it not a special character, basically? This one is, as long as it's not a special character, is it all numbers and alphabet? All right. When we go and use a print, as it says, we're going to print a string. We do have some special characters that will help us. And this is one. We can put that into a print statement. What that means is that we can take a big string and put some /n's in it, and it'll put it in different lines. Okay, so every time the print statement comes across a /n, it'll make a new line. So we actually call that the new line character. So it makes a new line that way. So yeah, print. You can do the end. All right, so this one works in the opposite way. You can say end equals that. So here we got two print statements, but this one says end equals that. What that means is it's going to do the opposite of a new line. So normally when we have a print statement, it's going to give you a new line. But if you say end equals an empty space, then it's not going to go a new line. So when you do your next print statement, you see that you get everything on the same line. So it's just a way of not going down to a new line. We can say end equals blank. And so that's maybe you may find that useful too. All right, that's kind of the end of that lecture. So going to pause for a second.